50 million years ago, the ancestors of today's rhinoceroses did not look like living tanks. They were smaller, more lightly built animals moving through the ancient forests of the Eocene, belonging to an evolutionary world in which the rhinoceros lineage was only beginning to emerge. Their descendants would eventually become some of the largest and most heavily built mammals ever to walk the planet. But evolution did not design the rhinoceros in a single stroke. There was no moment when nature simply decided to build an armored tank. Instead, generation after generation, different rhinoceros lineages experimented with size, body shape, teeth, limbs, skulls, horns, and skin. Some became enormous. Some became bizarre. Some became runners. Others evolved barrel-shaped bodies that looked more like hippos. Many never developed horns at all. And from this extraordinary evolutionary experiment eventually emerged the rhinoceroses we recognize today. To understand the modern rhino, we have to go back to the beginning. During the early Eocene, roughly 56 to 50 million years ago, the ancestors of rhinocerotoids were already diverging from the lineage that would produce modern tapirs. Fossil discoveries from Asia have revealed some of the earliest rhinocerotoids, showing that the split between the two groups occurred very early in the history of modern odd-toed mammals. These animals were not miniature versions of today's armored giants. They belong to a far more diverse world of small and medium-sized herbivores living in warm, humid environments. The rhinoceros body plan was still being invented. And that is the first great misconception to destroy. The rhino was never simply a defenseless animal that gradually put on armor until it became a tank. Evolution doesn't work like a construction project. There is no blueprint. There is no predetermined destination. Instead, every generation inherits a mixture of traits, and those traits interact with an environment that is constantly changing. Climate shifts, vegetation changes, competitors appear, predators evolve, new habitats open, others disappear, and populations that possess combinations of traits that work well under those conditions are more likely to survive and reproduce. Over millions of years, those small differences can accumulate into something almost unrecognizable. The rhinoceros lineage is one of the greatest examples. Fossils reveal a remarkable diversity of extinct rhinos. Some were relatively small. Some were long-legged runners. Some were adapted to grazing. Some had unusual skulls. Some possessed spectacular horns. Others had none. And one branch produced Paraceratherium, an enormous hornless rhinocerotoid that became one of the largest land mammals known to science. The history of the rhinoceros was therefore never a straight march toward armor. It was an evolutionary explosion in which different lineages repeatedly tried different solutions to survival. Then something remarkable happened. The rhinoceros body became increasingly specialized. Modern rhinos can weigh well over a ton, with some species reaching several tons. Their limbs are built to support enormous mass. Their skulls are reinforced for powerful feeding and, in some species, combat. Their bodies are compact, muscular, and extraordinarily difficult for most predators to overpower. But perhaps the most famous feature is not beneath the skin. It is the skin itself. Look closely at a rhinoceros, and what appears to be a simple hide begins to reveal something far more complicated. Beneath the surface is a dense network of collagen fibers. In white rhinoceros skin, researchers have found a highly organized, three-dimensional arrangement of relatively straight, strongly cross-linked collagen fibers. The dermis is substantially thicker than would be expected simply from the animal's body size, and its mechanical properties allow it to resist stretching, tearing, and compression. This is biological engineering at an extraordinary scale. Collagen is one of the fundamental structural proteins of the animal body. It gives connective tissues their strength. But in rhino skin, the organization of those fibers creates a structure capable of handling enormous mechanical stresses. Imagine a network of microscopic cables running through living tissue. Pull on it, and the fibers resist. Compress it, and the structure absorbs the load. Strike it, and the force is distributed through a complex material rather than concentrated at a single fragile point. It is not a literal bulletproof vest. It is not steel. And the thickness of rhino skin varies substantially across the body and among species. So the popular claim that every rhino possesses a uniform 3-inch thick hide is misleading. But the underlying reality is arguably more impressive. The rhino does not carry a separate suit of armor. Its armor is alive. It grows. It repairs itself. It contains blood vessels, nerves, glands, muscles, and connective tissue. And it has to perform another job that armor manufacturers rarely have to consider. It has to keep the animal cool. This becomes especially obvious in the greater one-horned rhinoceros. Its enormous body generates tremendous amounts of heat, and its characteristic folds are more than visual decoration. Research using CT imaging and microscopic analysis found connective tissue, cutaneous muscles, and small blood vessels within the folds. These structures appear to help transfer heat toward the skin, providing a thermoregulatory function in hot environments. The folds therefore create an extraordinary compromise. Protection on the outside, cooling underneath. Strength without turning the animal into a rigid shell. This is not armor in the medieval sense. It is something more sophisticated. It is living material engineered by evolution. But the rhino's defense does not stop at the skin. Because mounted on the front of the skull is one of the strangest weapons in the mammalian world, the horn. Unlike the horns of cattle, goats, and many other hoofed mammals, the rhino's massive horn does not possess a conventional bony core. It is composed entirely of keratin, the same broad family of structural material found in hair, nails, claws, and hooves. But that simple description hides an extraordinarily complex architecture. Microscopic keratin structures are organized into dense layers and filaments, producing a material capable of enduring substantial mechanical loading. The result is a weapon that grows continuously. It can be worn down, it can be damaged, and it can grow back. The shape we see is also partly the product of wear. Differences in the material's composition and resistance to degradation help produce the characteristic pointed form of the horn as the animal uses it and as environmental exposure alters its surface. And in 2026, scientists are still studying what makes this bizarre biological material so mechanically interesting. A study published in April 2026 examined the architecture of rhinoceros horn and used CT scans, compression experiments, and computational damage modeling to design a 3-dimensional biomimetic lattice inspired by the horn's fiber gradient structure. After optimization, the experimental structure increased its maximum load capacity by nearly 29%, while adding only about 3% to its weight. The research was not a simulation of a rhinoceros charging a predator, but it demonstrated something important. The microscopic architecture of rhino horn contains design principles that engineers are still trying to understand and reproduce. Nature built the prototype millions of years ago. Engineering is only now trying to reverse engineer it. But why did rhinoceroses develop such extraordinary structures in the first place? The answer is not as simple as saying predators forced them to. Predator-prey relationships undoubtedly form part of evolutionary history, but the fossil record does not provide a single story in which increasingly powerful carnivores simply forced rhinos to become increasingly armored. Rhinoceros evolution involved many pressures at once, including diet, habitat, locomotion, competition, body size, sexual selection, and interactions between species. Predators were part of that world, and some were formidable. During the Paleogene and Neogene, rhinos shared ecosystems with large predatory mammals, including hinodonts, nimravids, amphicyonids, and eventually true carnivorans. But predator pressure varied dramatically across time and geography. There was no single prehistoric apex predator responsible for building the modern rhino. Instead, evolution repeatedly tested different rhinoceros designs against changing environments. And some of those designs were extraordinary. Some rhinoceroses developed enormous bodies. And some of those designs were extraordinary. Some rhinoceroses developed enormous bodies. Some developed elaborate horns. Some became specialized grazers. Some evolved into long-legged runners. Others became heavily built, short-legged animals. The diversity is a reminder that the rhinoceros was never simply a defensive animal. It could be a grazer, a browser, a runner, a fighter, a territorial giant. And in some species, the horn became a weapon not primarily for killing predators, but for confronting members of its own species. That distinction matters. Evolution does not have to produce a weapon specifically to fight lions. Sometimes a weapon evolves because individuals compete with one another for territory, mates, or dominance. Once that weapon exists, however, it can become useful in other conflicts. The rhino, therefore, carries a strange combination of defense and offense. Its skin protects the body. Its skull supports a powerful horn. Its massive muscles drive the body forward. And its sheer size creates another defensive advantage that requires no specialized tissue at all. Intimidation. A full-grown rhinoceros is an enormous visual signal. The silhouette alone tells almost every predator on the African landscape that this is not an easy target. Lions can kill rhinoceroses under particular circumstances, especially vulnerable young animals, but attacking a healthy adult is a dangerous proposition. The rhino's mass, horn, speed, and ability to charge can transform an apparent predator-prey relationship into a potentially fatal confrontation. The armor, therefore, begins working before the first physical contact. The predator sees the animal. It calculates the risk, and sometimes it walks away. That may be one of the most efficient defenses evolution ever produced. You don't have to survive an attack if you can convince your opponent that attacking is a terrible idea. But this ancient fortress has a weakness. It cannot defend against everything. A rhinoceros can survive wounds that would be devastating to many other mammals. Its skin can withstand tremendous mechanical stress. Its horn can endure impacts. Its body can absorb punishment. But none of that prepared it for a predator that does not attack the animal itself. The modern threat is human technology. Poachers do not need to overpower a rhinoceros in combat. They can use firearms. They can use vehicles. They can track animals over enormous distances. And the very structure that evolution spent millions of years refining has become the reason the animal is hunted. The horn, that once served as a biological weapon, became a commodity. The armor that protected the rhinoceros from predators became irrelevant against organized poaching. And this is the brutal irony of the modern rhinoceros. Evolution built a fortress for a world of teeth, claws, competition, climate, and physical struggle. But evolution had never encountered humans with modern weapons. The rhinoceros can survive the bite of another animal. It cannot evolve armor against a rifle. It cannot grow skin thick enough to stop habitat destruction. It cannot charge climate change. And it cannot protect itself from the loss of the landscapes on which its ancestors survived for tens of millions of years. Today, the future of the rhinoceros depends on something completely different from the evolutionary forces that created it. Conservation, protected areas, anti-poaching operations, habitat preservation, scientific monitoring, captive breeding where necessary, and international cooperation. Because the rhinoceros is not simply another large mammal, it is the surviving fragment of an evolutionary dynasty that once contained an astonishing variety of forms. For roughly 50 million years, rhinocerotoids experimented with almost every possible version of the body plan. Small, large, hornless, horned, fast, heavy, forest-dwelling, grassland-adapted, and enormous. The 5 living rhino species are what remains of that extraordinary history. 5 surviving branches from a family tree that was once far larger. And when we look at a rhinoceros today, we are not looking at an animal that was simply built to be a tank. We are looking at the accumulated result of millions of years of evolutionary experimentation. Its skin is a structural material. Its horn is a living keratin composite. Its folds can help regulate heat. Its skull supports a weapon. Its body converts enormous mass into protection. And its silhouette can make predators reconsider the attack before it even begins. That is the real brutality of evolution. It does not build perfect creatures. It builds creatures that are good enough to survive their particular world. For the rhinoceros, that process produced one of the most extraordinary living machines on Earth. But the world has changed. The predators have changed. The landscapes have changed. And now, the greatest threat facing the rhinoceros is no longer something evolution can solve. The ultimate land tank has spent 50 million years surviving nature. Now, its survival depends on us. Because if these ancient giants disappear, we will not simply lose an animal. We will lose one of the last living witnesses to an evolutionary experiment that began more than 50 million years ago. A creature whose armor was written not in steel, but in collagen, whose weapon was forged not from bone, but from keratin, and whose survival story is still being written. The question is no longer whether the rhinoceros can survive the predators of its past. The question is whether humanity will allow the ultimate land tank to survive its future.